Welcome back to another exciting chemistry lesson. In this lesson, we are going to look at how to determine the shape of a molecules based on the Lewis dot structure. Now, sometimes we are not given the Lewis dot structure, so you have to figure out how to draw the Lewis dot structure for particular molecules. Now, in this case, we have the Lewis dot structure given to us. So how do we determine the shape of the molecules? Well, we use this particular molecular model theory, and that is called the Vesper Model. Now, Vesper is an abbreviation for valence shell electron pair repulsion. Now, based on the Vesper theory, double bond and triple bond are treated the same way as single bond. But the lone pair, remember, we talk about electron. They would do what? Electron, they repel each other. So the lone pair electron that is not involved in bonding, like this one, they would take up more space and it has more repulsive forces. So there, it's gonna manipulate. Therefore, it's gonna affect the overall shape of a molecules. Now, before we move on to label the shape of each molecules, let's review. We learned how to determine the hybridization of a central atoms based on the number of groups, right? So this term here, where it says number of electron pair, the better term is going to be groups, okay? And remember, we treated single bond and double bond and triple bond the same way. So let's look at this. So before we move on, again, this is groups, just the way we determine hybridization. The first type of shape we have is linear. Linear, think of the word line. It looks like a line, so don't get tricked by this, okay? Think about the basic term. Now, when we have a line, we have the degree of 180 degree. For example, like this one right here, although we don't have a central atom, but it looks like a line, so therefore it's linear. Now, this case we have sp hybridization. Remember, two groups, one is S and one is P. When we have three groups, in this case, what do we have? 1, 2, 3. Well, in this case, the hybridization is sp2. That is 1s and 2p. In this example, if you notice, this lone pair is treated as a group. In this case, we have the Trigonal Planar. Basically, each one of them has a degree of 120 degree. So if we take 360 divided by 3, what do we get? 120. But what happens when one of the group is a lone pair? Look at this. Remember, the lone pair take more space, right? So it's gonna push this. So therefore, look at this degree. The degree is going to be less than 120 degree. So that's very tricky. So a lot of your test question will ask you about this particular degree, and you have to realize it is less than 120 degrees. Now let's go down to the next group. We have 4 groups total. In this case, one is coming from S, the other 3 must coming from P. So therefore, for the very basic one where we have all the single bond attached to a central atom, we have tetrahedral. Tetra is a prefix for 4, so therefore 4 group. Okay, now what happens when one of those become a lone pair? Remember, the lone pair take up more space, so it push down, right? So it push down. So therefore, now the degree is still 109. It is less than 109. So that's the tricky part, okay? So if you put 109, it will be incorrect. Now, what happens when 2 of them become a lone pair? So basically, we have this now, so it takes more space, right? So therefore, we have bent. Notice how we use a shape bent to describe where we have a lot of lone pair that push the rest of them downward, okay? So therefore, the degree now even less than 109. So that's very tricky, so keep that in mind. So here we have an image of the Lewis dot structure, where in this case, this is drawn as 3-dimensional, where we have just basic Lewis dot structure. So let's do some practice problem. What is this gonna be? Well, this is gonna be linear. You can see that is a line. So we just have to use a common sense there, right? Although we don't have a central atom, but it looks like a line. Well, in this case, what's the next one gonna be? This is water right here. So we know it has 1 group, 2 group, 3 group, 4 group. It has 4 group, but look at the 4 group, right? So sp3 hybridization, but in this case we have the lone pair. What do we have? We have 2 lone pair, so therefore this is going to push it, and this has the shape of bent. So the degree is less than 109 degrees, okay? Now in this case we have another molecule with 4 groups, but one of them is a lone pair. So therefore we look at this one here. So therefore, what is the shape going to be? It is trigonal pyramid. And it has a shape of a pyramid like that, as you can see right there. Now let's look at this one. So this is the central atom right here, carbon. And remember, double bond and triple bond are treated the same way as single bond. And you can see that this one has no lone pair at all. It just looks like a line. So therefore, this is linear. And it has a degree of 180 degree. Let's look at this one right here. We have triple bond and we have a single bond. Remember, triple bond is treated as the same way as a single bond. So therefore, this is also linear as well. So far, I only put the shape of the molecules, but you are going to be responsible for knowing the degree of a particular shape as well. So now let's go on and do some more practice problem. In this case, we have ions. As you can see, we have 1 group, 2 group, and 3 group. So we go to 3 group and it has a lone pair, so we know it is bent. There you go. Let's go to the next one. Here we have 1 group, 2 group, 3 group. So again, going back to this one, we have 3 group and it's all attached to a particular atom, so therefore it's trigonal planar. And lastly, what do we have? We have 1 group, 2 group, 3 group, and 4 group, and that is just tetrahedral. And that is how you look at the Lewis dot structure to determine the shape of the molecules. But probably the most important part is knowing how to draw the Lewis dot structure in the first place. And as always, if you have any difficulty or any question, take a picture of your work, put in the forum, and we will help you from there. And we'll see you next time on another exciting chemistry lesson.